This tutorial focuses on significant figures, which are affectionately known as Sig Figs. Alright, so this is a chemistry student's topic that they love to hate. And basically, if you just sit down right now, learn the rules of Sig Figs, you're going to save yourself a lot of grief in this class and any future chemistry class that you'll take. So let's go ahead and start by defining what a significant figure is. And significant figures are the number of figures in a value or a number that are known with some degree of reliability or certainty. Okay, so it's the number of figures in a value known with some degree of a reliability. So what we're going to do is we're going to talk about numbers or values and break numbers into two different types, exact numbers and inexact numbers, and see how this relates to Sig Figs. Okay, so exact numbers have no uncertainty whatsoever. They are known exactly. That's why they're called exact numbers. So there's no uncertainty in these numbers or values. So inexact numbers have uncertainty associated with them. So they're not known with 100% certainty. There's some uncertainty in these numbers. Okay, and so what does that have to do with Sig Figs? Well, for exact numbers that have no uncertainty, we know every number with 100% certainty, with 100% reliability. That means they have an infinite number of Sig Figs. So we can consider these having an infinite number of significant figures. Okay, for inexact numbers that have uncertainty, this is where we count the number of values, or the number of figures in a value that have reliability or certainty associated with them. So inexact numbers have a certain number of significant figures associated with them. And we're going to learn the rules to determine the number of Sig Figs for these in just a second. Okay, so what's an example of an exact number? An exact number is a numeric definition. Okay, so what I mean by this is a numeric definition that 1 dozen is exactly 12. If I tell you you have a dozen, you know you have 12. So a dozen donuts, you know, are exactly 12 donuts if you buy it from the store before someone gets it and starts eating them. And so infinite number. So 12.00000000 with like infinite number of Sig Figs there. Also, exact numbers or numeric definitions are things like conversion factors, metric conversion factors. We know that in a liter, there is exactly 1,000 milliliters. Or in an inch, there's exactly 2.54 centimeters. Okay, so those are numeric definitions, and they're considered exact. Also, whole numbers used for counting are considered exact numbers. So, right, I count the fingers on my hand, the toes on my feet. I have exactly 10. So those are considered exact. Also, you check into your lab drawer, you counted 5 large test tubes, you have exactly 5 large test tubes. Inexact numbers, I mentioned this before, any measurements that we take in chemistry are inexact, and we have to know how reliable those measurements are. So any measurement you're going to be taking in lab and writing down, you need to consider significant figures. That's why it's really important. Okay, so what we're going to do now is look at the rules for figuring out the Sig Figs in inexact numbers. So we're going to have 5 rules for determining Sig Figs, the number of Sig Figs in inexact values or numbers. Okay, so rule number 1. All non-zero digits are significant. Okay, so we're going to look at an example. Our first example, 1.2 grams. Okay, they're all non-zero, so how many Sig Figs are there in that number, in that measurement? That's right, 2. 2 SF, 2 Sig Figs. Okay, next example, 1.234 grams. Right? Oops, I already started writing it there. We have 4 non-zero numbers, so 4 SF, 4 Sig Figs. Okay, second rule, that should be pretty easy. Our second rule is that zeros in between non-zeros are significant. So zeros between non-zeros are considered significant. Okay, so we're going to look at an example. 1.002 milliliters. How many sig figs do we have there? Well, we have 2 zeros sandwiched between 2 non-zeros, so we have 4 sig figs. Okay, next example, 307 grams, right? 3 sig figs. We have that 0 sandwiched between 2 others, so that's 3 sig figs. Rule number 3. All zeros to the right, or all leading zeros to the left of non-zeros are not significant. So all leading zeros, that's to the left of non-zeros, are not significant. So, example, 0.001 grams, right? We have non-zeros to the left of our non-zero, and so those are insignificant. They're just placeholders. So how many sig figs do we have there? That's right, just 1 sig fig. Okay, our next example, 0.0320. Okay, kind of threw this one in you. How many sig figs does that have? Well, we have a 0 to the left of a non-zero. That doesn't count. We have our 3, we have our 2. That counts. Well, I threw in another 0 in there. So this one actually has 3 zeros and 3 significant figures. And that's going to be part of our next rule. Okay, our next rule is that if we have zeros to the right of a non-zero, they are significant if the number also has a decimal place. Okay, so zeros to the right of non-zeros, like we just saw in our last example, are significant if there's also a decimal point. So if that number has a decimal point. Just like before, 0.0320, we have that 0 to the right of the 2. There's a decimal point there, so we consider it significant. So let's look at a few other examples. How about 0.003200? So I threw in a similar one to what we saw. 0.003200 grams. You notice all these numbers have units associated with them since this is a chemistry class and not a math class. Okay, so those first zeros are just placeholders. We have our 3, we have our 2, and then those 2 zeros to the right, those are considered significant since we have a decimal point. So here we have 4 sig figs. Okay, next one. How about just 100, 100 grams? Okay, so some textbooks do this differently. I'm going with your Zoomed-all text, and basically, so we have zeros to the right of our non-zero. There's no decimal point at all, so we only have 1 sig fig here. Okay, so 1 sig fig. Sometimes this can be considered ambiguous. Like I said, some textbooks, we'll get to that in Rule 5, a better way to write this number in Rule 5. All right, so what if I put 100 period, or decimal point, grams? 3 sig figs. Since we have that decimal place now, those zeros to the right of our non-zero are now significant. All right, so to make those, those last two, 100 with no decimal point or period, and 100 with that decimal point, to make it a little easier, if we write the number in scientific notation, all the numbers when expressed in scientific notation are considered significant. So if the number is expressed in scientific notation, so I'm going to assume you know how to do that. If you don't know how to do scientific notation, you'll need to talk to your instructor or look in your book. So if the number is expressed in scientific notation, all the numbers are significant. So let's look. I have 1.0 times 10 to the 2 grams. So that's 100 grams. But I wrote it in scientific notation. So all those digits, the 1 and the 0, are considered significant. So that then is 2 sig figs. Great. If I wrote 1 times 10 to the 2 grams, then that has 1 sig fig. It's just like writing 100, right, with no decimal point in our previous example. But it's just a little bit less ambiguous. So we know for sure, okay, we just have 1 sig fig. So anything, like 100 or 1,000 or 200 or with zeros at the end, I would like you to write in scientific notation. It just makes it a little bit less ambiguous. Okay, last one then, 1.00 times 10 to the 2 is going to be our 3 sig figs, just like we had it before if we expressed 100 with our decimal place. All right, so scientific notation just gives you a way of being very clear about your significant digits. Okay, so that ends this tutorial about the rules for Sig Figs. Make sure you check out the next tutorial, which is going to be about Sig Fig rules when you're doing calculations.